What's going on, guys? This is Matt Chinella here with Matt Conklin, Welding Applications Engineer for ABB Robotics, and Scott Huber, Key Accounts Manager for Sensors and Robotics at ABB and Abicor Binzel, respectively. We're here at ABB Robotics in Auburn Hills, Michigan, talking seam tracking for arc welding applications. Scott, I want to start with you. First question I have about seam tracking. Tell me how seam tracking has grown from its first inception into today's seam trackers.
20 years ago, the CPUs weren't as strong as they were. They couldn't handle much data. Today, we're able to take that data, process it faster, allowing for closer look-aheads, shinier materials, different weld joints. The memories in these are becoming, so we can hold more jobs. Look at different applications. We're allowed a 3-line technology, so we're able to get that data back in, process it in milliseconds, be able to get the data to the robot and make those corrections and offsets as needed.
What should people know about seam tracking if they're looking at it right now for their robotic welding application?
With optical seam tracking, it's there to enhance what you currently have or what you would like to do. It's not the fix-all cure, but it can do a lot. It can definitely help in parts that are not fitting up correctly, that they vary a little bit, but they have to vary within reason. We can't just have parts that are scattered all over the place that, we just say, hey, we're going to set them down and weld it. There are some limitations, but overall the process is very, very good and reliable for enhancing what you currently have or what you would like to do.
There's a lot of seam tracking options out there. Not all of them are made the same. Some of them vary in features and spec. So Scott, I'll start with you. What are some of the evaluation criteria you tell a person who's looking at seam tracking? What separates optical seam tracking solutions from one another?
So when you're looking at, that's a great question too, because when you're looking at going to optical seam tracking, a lot of people will look at their parts. They'll have off-location welds. They'll look at tooling that's expensive, and can I set back on my tooling a little bit? So when evaluating going to optical seam tracking, what you have to look at is, what does my weld joint look like? What's my material type? What is my end goal? Because like Matt alluded to, it doesn't fix your non-weldable product. So if your part's not weldable to begin with, if you got large gaps, if the material fit up isn't allowed to be welded, optical seam tracking is not going to fix that. What it's going to do is, if you have a part or the weld joint is just moving in different locations, because today's robots are highly repeatable, they go to the same spot every time. What optical seam tracking does is allow the robot to have a set of eyes per se. So it's going to look at the joint, it's going to say, hey, this is where the joint is, this is where I was taught, and then it's going to adjust to that point. So you really have to look at, does optical seam tracking apply to that process? I'm going to let Matt take over, talk a little bit about the robot side of it, but that's what we'd look at to even say, yes, you can put an optic on this. Then we go to our robot partners and say, hey, this is what we're looking at, it can do it. What do you guys need?
So a lot from our end, we start looking at, okay, is there access? Can we fit the torch and the camera in there? Do we have to use a different torch, which Binzel has a great line of torches, and do we have to mount the laser in a different orientation? One way that we'd like to qualify these different leads and things is through one of our tools, RobotStudio, which is an offline programming tool. We actually have 3D CAD models from Binzel. We actually bring them in, snap them to the robot, and start checking reach offline even before the tooling is built. And where we kind of, start looking at differences here is through the arc seam tracking is one option that we can do, but it has its limitations also, just like every other process. Thinner materials doesn't do as well. Aluminum doesn't do as well. And that's where the TH6 and a lot of the other models really excel on the shiny materials. On aluminum, does a great job. So there's a lot of opportunity there for optical seam tracking.
Why is optical seam tracking, in your opinion, the most effective solution for seam tracking?
Well, the aspects of optical seam tracking, it's zero contact. We don't have to touch the part. We're able to have a standoff distance. We're able to get real-time data. We're able to do the different material types. Aluminum is one of the hardest things to do through the arc seam tracking. Thin material. So optical seam tracking gives us those ability to track the materials that we're never be able to track before. Aluminum diamond plate, for instance. We're able to track that in a butt joint, in a lap joint. Historically, that was not a tracking solution. With today's technology, and the TH6 allows us to be able to do that. The zero gap scenarios. So if you got a zero gap butt joint, TH6i is going to be the solution for you at that point. We just want to look at what material it is. You know, optical's given us a lot of advances versus touch sensing. Touch sensing's slow. Optical seam tracking, you can typically find a weld joint within about a quarter second. And with touch sensing, you're going to be about 3 to 5 seconds per search vector. So if you go up with a 2D, you're into that 10 second. If you're doing a 3D touch, you're up to 15 seconds just to find the start. Then typically, if it's a straight line, you're going to find the start, you're going to find the end, connect the dots. If you're going through the arc, you're going to have a weave on there, which is very slow. Optical seam tracking, what happens, we find the joint, we're able to track it. Typically, you're able to increase your travel speeds, so better production rates. You're able to stay in the weld joint. You can always usually jump up a wire diameter because now I'm not as finicky, I can go faster with everything. So optical seam tracking has a lot of benefits that I would say the non-traditional or non-typical anymore. We find a lot of situations where, through the arc was the solution, and optical seam tracking is kind of trumping that going forward. The systems are becoming smaller. We're able to get in, and with technology right now, we're able to pre-scan some parts, drop off the scanner, come back in, and run those travel speeds at higher rates.
We talked a little about comparing seam tracking to other solutions. Tell me from a communication standpoint, joints and material standpoint, how's seam tracking, optical seam tracking in particular, how does that compare to solutions like touch sensing or like through the arc seam tracking from a performance standpoint?
Right, yeah, they all have their limitations. When you look at it as a whole, optical seam tracking has a lot more opportunity. If you're doing a lot of different joints, thin material, thick material, multi-pass, single pass, different materials in itself, whether it be steel or aluminum, it really has the most variety of things that it can handle. When you start looking at weld guide and things like that through the arc seam tracking, the limitations stop at aluminum. We can't weld guide with aluminum. And certain stuff we have a little bit harder time with pulsing, things like that. So there's limitations there. The same with touch sensing. When you start touching either the cone or the wire to the part, if it's a heavy mill scale, we run into issues there with not getting an accurate touch sense. There could be things on the nozzle, the wire could be bent. There's a lot of factors that go into play there. To get a really good clean touch sense, you need to first send it over to the torch cleaning station and snip the wire, which, as Scott has alluded to, costs time. So there's a bunch of different things that add up that help us decide on what is the best solution for the customer at the end of the day.
Where optical seam tracking has some of its limitations, it has to be in field of view. So if it can't be field of view, it has to be the right torch angles, has to be the right camera angles. Touch sensing, as long as you can reach the thing and get a good hit, you can get the read back for it. We're looking at around tooling, physical reach of the robot. Can I physically get there? Those are the limitations that you're looking at. You got a chunk of steel sitting on the front side of your torch or somewhere around the peripheral of that torch that just gets in the way sometimes.
I want to talk to you guys about cycle time with optical seam tracking. For any manufacturer out there, time is money. You want to be welding and on the arc as much as possible with your robot, right? So tell me how optical seam tracking does in terms of cycle time against other seam tracking solutions.
Well, what we find is touch sensing versus seam finding with an optical laser. Touch sensing, like we talked about, it's very slow. It's 3 to 5 seconds per search vector. Optical is about a quarter second. So right there, you can save anywhere from 10 to 15 seconds per weld. Sometimes if you're doing arc starts and arc ends, you're up around 20 to 30 seconds just for searching alone. With the optical seam tracking, you never have to search your ends. You're always searching your starts.
If we can keep the part within the field of view on the camera, we have a PreProcess buffer. So we can actually buffer the distance from the laser to the arc, and then we can strike the arc at where we want to and be in position already. Another way that we can do it, if we're not going to be able to find it within the window, we can actually do a search and find the edge and then start from there. And as Scott has said, you know, that is all done much quicker with optical tracking.
Is there, for different optical seam tracking solutions, are there ones that are faster than others, maybe because they do real-time joint scanning compared to pre-scanning or anything of that nature?
Yep, so there's other optical solutions on the market. One thing that separates TH6D is 3 lines. So we got 3 lines of separate data coming back. We're averaging those together, giving us a more reliable path. The information is 3 times better than the other solutions out there. So with that processing coming in, we're able to make sure that the data the robot's receiving is correct data for one, and we're not what we call it squirrel chasing things that aren't there. And the paths are a lot cleaner, reliability's there. You're not relying on mill scale or the cleanliness of a joint. As long as the weld joint's visible in field of view, we're able to track it and decrease those cycle times, and in a lot of cases get better products.
Tell me about optical seam tracking from a usability standpoint compared to touch sensing or through the R.
Yeah, so this is a question that gets brought up quite a bit when we start talking to new users. You know, a lot of newer users are, you know, afraid to get into robotics, let alone optical seam tracking, because of the technology. But you know, the thing that I'd like to point out is technology in general is getting better and easier to use. I mean, people find it easier to acclimate to a touchscreen phone. You find, you know, people more easily acclimated to a computer and things like that. Well, industrial technology is gaining traction in that same way. You know, with our interface with the TH6, we have a really nice, easy to use GUI app that's very well laid out. The calibration and setup with the Binzel has been very efficient. We have a very simple calibration that we have to run. The setup itself is all Ethernet connections, and the TH6 viewer integrates really well with what we're currently doing on RobotStudio. So it's paired together really well.
With the ease of use, you know, the TH6D really comes in pre-programmed for all the basic weld joints. You don't have to build your own profile up. You select one of many that's in there already, and they come with every system. And all of our models that we have all connect to all the ABB robots, from even some of the older ones with the serial communications. So we can go from, you know, little older robots all the way up to the brand new ones with good communication, good setup. And as Matt has said, you know, the calibration's simple, it's easy, it's reliable. One thing I do like about the ABB product line is they're able to take and run our torch packages and our setup and use multiple swan necks. So if you got different TCPs, sometimes you talk about access. When we got into access into parts, you know, you've got this big chunk of steel out there, but really I need to get, you know, a longer swan neck so I can drop off the whole torch package, grab a new sensor torch combination, and get into that access. But that one might be different for this part. So there's a lot of flexibility that the ABB brings to the weld process and being able to get a true solution into the industry. I think with the Binzel torches, ScanSonic sensors, and ABB robots, you're going to find that the solution's going to be there for you.
Can you guys go into a little bit more detail? Tell me Tell me about the data the sensor's collecting, and then tell me what the robot does with that data.
We have 3 optical lines, and what that allows us to do is we're able to collect data not only in an XYZ, we can give you the deltas around the XYZ. We're collecting gap, mismatch, area in some cases. We have a plethora of data coming into our sensor, and we transmit all that data back to the robot. ABB does a great job of taking that information, applying it to what they're doing. They can do some stuff with the adaptive. Matt, can you describe when we give you this information, what are you guys doing with it?
There's so much data coming to us that we have availability to all of that. So as Scott was saying, with gap, just to start with, that's one issue that we see a lot, that there's a gap in the part. we can start controlling process and the robotic movement from there. If your gap starts to grow, we can do a couple of things. We can slow down the robot movement, so reduce the travel speed, or we can increase the wire feed speed to put more material into the part. Or we can start also adjusting weave data, or we can do a combination of all three. So there's a lot of availability to adjust on the fly with the amount of data that we're getting back from the TH6.
Why would you recommend optical seam tracking over other seam tracking solutions, or why would you recommend it for manufacturers who come to ABB?
Yeah, absolutely. We actually look at it from all ends of the spectrum. So, from somebody that's buying their first robot cell all the way up to an automotive or a tier supplier for automotive, for the simple fact of the ease of use, because that has always been the stopping point. Per se, is we don't want to get into this because it is very complicated and difficult. Well, nowadays with technology and the development, it has made it very easy to use.
Okay, well, that was a lot of great information. I want to thank you both so much for your time. If you guys have any questions about automated welding solutions, feel free to contact ABB Robotics or Abicor Binzel for your torch packages, sensors, robot periphery. This is Matt Schinella with Matt Conklin and Scott Huber. Thanks for watching, everyone. Have a great day.